Okay, so the first major topic was sampling distributions. There's really only like a handful of things that you have to know from that one specifically. The next thing was confidence intervals and hypothesis testing. For one mean. And so really that boils down to t-test and sorry, let's not do it that way. T-distribution and z-distribution, right? So how do I know which one it is? Sigma is unknown, and then sigma is known. Okay. I always tell students, when in doubt, use the t-distribution. Okay, that one's always the safer one, right? So how to do a confidence interval and a hypothesis test for one mean. Remember, there's no proportion on here. That's going to be the next exam. Okay. And then the other thing was confidence interval and hypothesis testing for two means. So that's two sample t-test, which is independent, and then match pairs, which is dependent. Okay. And then one other thing I can throw in here, sample size. That was another thing we talked about, right? And when you look at it, that's really all that we talked about, okay? Is these things related to one mean and two means, right? Doesn't seem like a lot, even though it feels like a lot, right? So let's go through that. Okay. So we can do that. Let's just talk about sampling distributions. So when you saw that question on the practice exam, you probably thought like, when did we learn this, right? This is like a long time ago. So that's why it feels so, old. Remember, that's when we discussed the whole idea of me taking a normal distribution and doing a bunch of sample means as my distribution. And then the law of large numbers says that this becomes normal if I take a large enough sample size, right? And so the biggest change that happened was, well, mu is still equal to x bar. The means don't change, but sigma became sigma x bar, and this is equal to sigma over square root n. That was the change that happened, right? And so when you're doing a problem, the whole thing was draw a distribution, find the points in between, and or outside or inside or whatever. And then all you have to do is a norm CDF, but instead of using, say, sigma, it's now sigma over square root n, right? So exact same as before, but sigma is now sigma x bar, okay? So we can just do an example. Given mu is equal to 37 and sigma is equal to 3.2, if n equals 9 and the population is normally distributed, then compute the following. First one, what is the probability? Okay, you can write this in several ways. Actually, let's do it like this. Probability, the let me just make sure I word this correctly, because I don't want to say it wrong. The sample mean is between 30, that's too big, 36 and 39. Okay, what's the probability is between those two numbers? All right, that's the question. So step one is to draw a distribution. You just want to draw a distribution. And if you want to engage a little bit, type in the chat for me what goes in the center at all times, right? What goes in the center of a distribution? If you want to engage a little bit, right? Well, what goes in the center is going to be the mean, right? So the mean goes in the center, so mu, which happens to be 37. Okay. And so now I'm just asking, what's the probability or the area between 36 and 39? Okay. Step two, and we'll have to go to a new slide, but are there any questions so far? Does anyone need more time to copy down this slide so I can pause the recording? That's why I asked. Okay. No one said anything. So step two is find sigma x bar. So sigma x bar is equal to sigma over square root n, which is equal to 3.2 divided by the square root of 9, which is equal to, let me calculate this off to the side, 3.2 divided by 3, 1.067. Like that. And then step three is to use norm CDF. Remember, we never ever use norm PDF, just CDF. Right? So norm CDF of your lower limit, comma, your upper limit, comma, mu, comma, sigma x bar. Like that. And so norm CDF of 36 and 39, where the center is 37, and then sigma x bar is 1.067. If you wanted to, you could just type in 32 over square root 9 in your calculator. It would accept it. It has no issues with that. So just to practice here, hopefully this calculator is working. So give me a sec. Looks like it does not want to work. So let me open up another one. Whoops, give me one sec, actually. This one that works. Okay, there we go. Just had to find one that works. Okay. Now we can resume. So skin change right there. So stat. Okay, whoops, wrong one. This is going to be something you do all the time. So second distribution, and then we go to normal CDF. Sorry, it's normal CDF, but because Excel uses norm, I just write norm. So normal CDF. And then the lower bound is going to be the 36. The upper bound is going to be the 39. And then this is going to be 37. And then this is going to be 1.067. Okay. And then you're going to paste it, press enter, and there's your area. And that's the answer. That's all you have to do. So the answer is equal to 0.7952. And make sure you round to the correct number of decimal places. Okay. Now, if I wanted to ask a question like probability less than 40, Okay, the probability that it's less than 40, actually, that might be too big. Let's do 36. Well, you do the same thing, except now it's going to be norm or normal CDF of 1 negative e to the 99, comma 36, comma 37, comma 1.067. So I go to my calculator and I do second distribution, normal CDF. I'm going to change the lower to negative 1, second e to the 99, and then my upper is 36. Everything else stays the same, and I get 0.1743. Okay, so 0.1743. Any questions on how to find the probability using a sample distribution? That's really the main aspect of what you need to remember from sampling distribution, right? And then just remember the law of large numbers. So law of large numbers. As n goes to infinity, the sample distribution of sample means becomes normal. Okay. As n goes to infinity, the sample distribution of sample means becomes normal. But any questions on that? I mean, that's all you really got to remember from that. Okay. So then now we'll dive into one mean, confidence interval, and all that stuff. So now let's talk about one mean, confidence intervals. We'll do the confidence intervals first. Okay. So remember, a confidence interval, I'll just abbreviate as CI, is the long-term probability of a series of intervals that may contain the population parameter. So remember, the 95%, the 99%, that's not about a single interval. That's about a series of many of them, right? We did that whole example in class where you have to do it a bunch of times and then like the majority of them contain the mu value or whatever. Remember that. Okay, it's not about a single interval. It's about many. And then there's this special one that, you know, kind of captures the whole thing, right? So that's the long-term probability, okay? Sorry, confidence level. Yeah, I got that backwards. It's confidence level. The confidence interval is the actual interval itself. The confidence level is the long-term probability. So we have two confidence intervals for one mean that we have to pay attention to. That's going to be the Z interval and the T interval, right? So Z interval and T interval. So then the question is, how do I know which one to use, right? Well, again, it just goes down to sigma is known, sigma is unknown. Okay, sigma is known, sigma is unknown. Okay, so then the population parameter is equal to mu. I'll write that down for both. Okay, so they each have that population parameter. The critical value well, that's going to be equal to Z alpha over 2 or Z alpha, right? So it depends on if you're doing a two-tail versus a one-tail, okay? And then the critical value for T is going to be plus or minus T alpha over 2 comma degrees of freedom, or T alpha comma degrees of freedom plus or minus, right? And so the Z interval doesn't care about degrees of freedom. The T does. So degrees of freedom is your sample size minus 1. So you just have to remember that, right? Okay. And so for each of them, they have their own computation, right? So the interval is mu less than x bar plus z alpha over 2, or I guess I should call it z star, okay, times sigma over square root n, like that, and then z star sigma over square root n, like that. And I forgot the x bar, minus, okay? And then for t interval, it's x bar minus t star s over square root n less than mu less than x bar plus t star s over square root n. Now, if you're wondering what is t star and z star, t star can be either of these two. It's just I don't want to have to write the formula twice, so it can refer to either of the two. So that's what it's referring to, right? So they're almost the exact same formula, right? So in class, I said standard error and margin of error are the same thing, and they really are, because depending on what textbook you read, they use them interchangeably, and some just kind of are nitpicky. So just to be consistent with the textbook, but it's not going to matter for the exam, I'll make sure of that. This right here is the standard error, okay? So that by itself is the standard error. And then when you multiply the whole thing together, that is the margin of error. So that's E, okay? So it's not going to affect you on the exam. I won't make it where you'll have to like know the difference between the two, because, you know, maybe I created that confusion on accident and I didn't mean to. It's just different textbooks use different slight variations on that definition. So once again, this is the standard error. And then the whole thing together is the margin of error. I'll just put MOE just to make it more obvious. Okay. So for that one homework question where it says calculate the standard error and margin of error, now you know how to calculate it. The standard error is just sigma over square root n or s over square root n. And then the margin of error is z star times that number that you got in the previous example. Okay. So someone asked, how do I know when to use z alpha and z alpha over 2? That's a good question. So this is the 2 tail, and then this is the 1 tail. So if it's the not equals case, right? So we'll write that down. Not equals implies alpha over 2, less than or greater than implies alpha. That's how you know. So it comes down to your alternative hypothesis will tell you. Okay, and we'll mention that when we do the hypothesis testing. Okay, and so on the calculator, this is going to be t interval. Sorry, wrong letter. This is going to be z interval. And then this is going to be t interval. Okay, and so that's what you want to use. And just to show you, okay, if you go to stat test and you go down to options number 7 and 8, there they are, right? So if you click on z interval, click over to stats, that's all the information you have to give it. And then if you go to t interval, same thing right there, right? So that's what you need to use, okay? Any questions so far? So we'll just practice finding a confidence interval. So example. Okay. Given X bar is equal to 70.1 and S equals 10.2. If N equals 11, find the confidence interval given a confidence level of 90%. Okay. So part of the exam, and like this is a question I can't answer during the exam, is like, which test do I use? Well, that's what I'm testing you on. Do you know which test you need to use? So practice right now. Which interval am I using? There is a what's it called? A clear indicator of which one I want to use. So if you want to type it in chat and guess just to see what you get, see if you get it right, which interval do I want to use? So this is going to be a T interval. And if you're not sure why, it's because of this letter S right here. That right there tells you that it's a T interval. Okay. So step one is to identify parameter. You don't have to do the step, but it is good habit. So I see X bar, so then mu is my parameter. This is a mean problem. Okay. Step two, identify test or interval test. Dang it. What is he doing that? Identify interval type. So I see S, so that means T interval. Okay. I see the S, so that means T interval. Step three, find X bar, S, and N. Now in this problem, I make it super obvious what they are, but on a, word problem, you have to dig a little deeper than that. So X bar is equal to 70.1, S is equal to 10.2, and then N equals 11. Okay. Does everyone see that? That's the information you need to fill it out in your calculator. How did I identify the parameter? Well, I want you to ask yourself this question. What are the parameters that we know? Mean, proportion, and standard deviation / variance. And the parameter of the mean is mu, right? X bar is the sample statistic. The population parameter of X bar is mu. Does that make sense? So if I see X bar, the parameter is mu. If I say p hat, the parameter is p. If I see S for a standard deviation problem, then the parameter would be sigma, okay? But the X bar is what tells me it's mu. Does that make sense? So now I want to find alpha. So alpha is 1 minus the confidence level, which is 1 minus 0.95, which is 0.05, okay? Now, in this problem, you don't have to do this, but actually, you know what? I'll do this a separate problem. We'll do it separately. Step 5, plug into calculator. I'll do it separately. Plug into calculator. So we are going to go to T interval. So let me go to stat, go to test, and then go all the way down to T, not Z, because if you do Z, oh, sorry. I'm glad you caught that, because that's such a common mistake, is that by default, people will think it's 95%, even though it clearly says 90%. I've seen it happen so many times where people will just instinctually, because we use 95% so much. So I'm happy you caught that, right? Okay, so T interval, my X bar is 70.1. My standard deviation is 10.2. My sample size is 11. And my confidence interval is 90%. Okay, So in this problem, we actually didn't need alpha, but you know, it's always nice to have it because maybe you're doing a hypothesis test. So, and then we calculate. Now remember, you only press enter once for these, not twice like the distributions. And my confidence interval is 64.526, comma, 75.62, sorry, 674. Okay. So this is the interval where I am 90% confident that the true value of the population parameter may exist in. Okay. I'm 90% confident that if I did a bunch of intervals, that the number, the population parameter, would be somewhere in between these two numbers. Okay. That's my confidence level interval. Okay. Any questions on that? So if I hypothesize, you know, just to kind of go a little bit further, if I had said H naught mu equals 77, like I hypothesized that it was 77, would this interval be in favor of 77 or against 77? Type in the chat. Would it be in favor of 77 or against it if I believed it was 77? This is the kind of thing you want to think about, right? So it's going to be against it because is it possible for 77 to be between those two numbers, 64 and 75? Is it possible for 77 to be in between them? No. So this interval is evidence against my null hypothesis. Okay. So that's what we're aiming for at the end of the day. Okay. Are there any questions on how to calculate the confidence interval? Since both X bar and S are given, why can't the parameter be sigma? Well, sigma is different. And in order for it to be sigma, like if you want to do a confidence interval for the standard deviation, you actually also need to know sigma. So we haven't done that one yet, so we don't have to worry about it, but it's a little more complicated for that one. The chi-square distribution is a lot more difficult than these, because it's not symmetric. So that's another issue you run into as well. But if I didn't give you X bar and I only gave you S, that would indicate that it's a sigma, because then you don't have an X bar, so it can't be mean, right? So you kind of use process of elimination. Any questions? Now, if I change this, so let's just think about this critically. If I change this to the symbol sigma, what's going to change? It's going to become a Z interval. That's it. If I use the symbol sigma, now it's a Z interval and everything is, you know, the same, except the number at the end might be a little different, right? So that all that changes when you change the symbol sigma. It's the same thing, right? Example, find critical value of alpha equal to 0.02 for a two-tail Z distribution. Okay, find the critical value of alpha equal to 0.02 for a two-tail Z distribution. Okay. So what I'm asking for is, what is the value? Okay. So do you see two-tail? That right there says Z alpha over 2. That's what that tells me, Z alpha over 2. So I'm going to have a negative Z alpha over 2 and a positive Z alpha over 2. Okay. And if alpha is 0.02, then the in-between point is 0.98. And then this area right here is alpha over 2, which is 0.01. And then this area is alpha over 2, which is equal to 0.01, like that. So then, Z alpha over 2 is equal to Z 0.02 divided by 2, which is Z of 0.01, which is equal to inverse norm of 0.01 comma 0 comma 1. That's how you actually calculate the critical value. So then you go to your calculator, you do second distribution, inverse norm, and you put in your alpha over 2, 0.01, and then you paste, and it's negative 2.326. So plus or minus 2.326, right? Now, if I wanted a one tail, well, then that just means I would use alpha instead of alpha over 2, okay? Left tail, negative z alpha. Right tail, positive z alpha. And that's the difference. So if you calculate the left tail, the right tail is just the positive version, right? So it depends. Two tail means the not equals case. Left tail means the less than case. Right tail means the greater than case. So you'll have to look for that notation. But if I don't say anything, then you assume it's a two tail, right? You always assume two tail unless told otherwise. Any questions on that? Okay. And then if you have to do a critical value for t, then it's the same thing, but you use second distribution inverse t. And then the degrees of freedom is n-1. Now, if you're using the table, then you'll have to use the table and you'll have to practice that one yourself. Okay. So now let's talk about hypothesis testing. Okay. Hypothesis testing. So I'm only going to do the t-test because of time more than anything. But the z-test is the same. Just change it to sigma, right? So just because of time, I have to only do one of them. So, you know, we're going to practice an example, but actually before we do that, H naught is the null hypothesis. Now, I know for some reason the homework did stuff like greater than or equal to. I personally believe that's wrong. They shouldn't do that because every other textbook I've ever used never did that for some reason. So I don't know why our textbook did that. So for us, and because I mentioned it in class so much, our null is always just an equal sign. Because if you do as an inequality with an equal sign, it's kind of ambiguous at best. So again, and I mentioned this many times in class, we just do equal. So H naught is equal. And then the alternative can be, you know, less than, greater than, or not equal. All right. So H naught, just to give you an example, mu equals 0. The alternative, mu does not equal 0. Mu is greater than 0. Mu is less than 0. This is a two tail. This is a right tail. And this is a left tail. Okay. Now, the inequality doesn't matter if it has an equal sign, honestly, but, you know, I usually just do without one. But any questions on that? Or we're just going to do an example. Test the claim that if the mean height of men is 68 inches, okay? Test the claim that if the mean height of men is 68 inches with a standard deviation of 2.7 inches, if you sample, okay, if you sample 27 men, no, I won't do 27. Let's do 11. If you sample 11 men, from a normally distributed simple random sample. Okay. So test a claim that if the mean height of men is 68 inches with a standard deviation 2.7 inches, if you sample 11 men from a normally distributed simple random sample, that there it is not different. Okay. I think that makes sense. So, step 1, population parameter. Okay, population parameter. So I see the word mean, I immediately think mu. Okay. That's it. Mean mu. Step 2, test. Well, because it's the mean problem, it's either going to be Z or T. So is sigma known? No, then it's a T test. Okay. We do not know sigma. Now I know what someone might be thinking. Wait a minute. Didn't you say the standard deviation is 2.7? Well, let me ask you a question. Do you see the symbol sigma? I do not. Do you see the word population standard deviation? I do not. So then it's automatically a sample standard deviation. So I have to make it obvious to you that it is the population standard deviation sigma. So if I don't, then it's the sample. Okay. Step 3, H naught and HA. Okay. So my null hypothesis is that mu equals 68 inches. Okay. I said that I'm going to test the claim that if the mean height of men is 68 inches with a standard deviation of 2.7, okay, then I want to see from a sample of 11 men that it's not different. Okay. Oh, you know what? Sorry, I made a mistake. One more second. Just got to add an extra thing. From 66 inches. I have to give you the one that I gave you was X bar, so that's my fault. Okay. Oh yeah, and alpha. We can just add at the end. Thank you. Yeah. So that it's not different from 66 inches. So my null hypothesis is that it is 66 inches. And then my alternative is that it is not 66 inches, right? That's what I'm testing. Now on the exam, they'll be much more worded nicely, so it's not confusing. It's just when you make these up off the top of your head, they're not as nicely written, but hopefully you get the main idea. Okay, step 4, find alpha. Alpha equals 0.05. Okay, that's it. Step 5, find p-value. Now, you don't have to do this because we don't really usually need it, but let's just find step 5 is find the test statistic. We should at least compute it once or twice because, maybe a question just says, hey, what's the test statistic, right? So the test statistic is going to be T equals X bar minus mu over S divided by square root N. So that's going to be 68 minus 66 over 2.7 divided by the square root of 11. Okay. This would just be given. 0.05 would be given. You don't ever have to think of what alpha is. It's just given to you. Does that make sense? I just forgot to give you one, so that was just me adding it at the very end because I forgot to give you one. So if you calculate this correctly, which I'm trying to do right now, I got 0.70 sorry, it's not 7.0, 741. That is my test statistic, okay? And the only reason I'm calculating it is because maybe the homework requires you to calculate it, right? Step 6 is find p-value. Now, if you just go to the calculator, go to stat, go to test, go to t-test, type in your information. So this would be 66. This would be 68. This would be 2.7. And this would be 11. And then the not equals case. And then we press enter. Did I calculate it wrong? Hold on, I think I calculated it wrong. Oh, yeah, I did calculate it wrong. Sorry. I divided by square root of 1, not square root of 11 on my calculator. So this is 2.457. But luckily, my calculator also calculates it here too. So you don't even have to do that by hand because your calculator does the work for you as well, right? So that's there. And then my p-value is equal to 0.033. Okay, so that's my p-value. And so from that, I can make my determination or my decision. Do I reject or fail to reject? So let's go to the next slide. Number 7, reject H naught or fail. Okay, reject H naught or fail to reject H naught. So you need to make sure you have this in your cheat sheet because this is going to be important. The p-value less than alpha, you reject. P-value greater than alpha, you fail to reject. Okay, that's very terrible. Reject H naught. So my p-value was 0.0339, and that's less than 0.05, so I reject. Okay, I reject H naught. So step 8 is your conclusion. There is sufficient evidence to reject H naught and say the men's height is not 66 inches. Okay, there is enough evidence to say that the alternative is, or the hypothesis is not true. I'm not really proving the alternative, although you can kind of say that. You're just saying that the null is not true. Yeah, but I'm not also proving the alternative is a specific number. I'm just saying it's bigger than 1. So that's kind of the idea. Any questions on that? And so let's do sample size now. This is the last from the sample sizes. So this formula is provided to you in your Excel sheet. Sorry, not Excel sheet, wrong class. On your, what's it called? Formula sheet. There we go. Blanked on that. Okay. So Z alpha over 2 times sigma divided by E. Okay. So let's just do an example. Given you want to test battery life at a plant. How many batteries must you test if you want to be within a margin of error of 2 and a standard deviation of, trying to make sure I don't make this too big. I don't know, 8. No, that's too big. 5.4 and confidence level of 99%. Okay. So I'm gonna pause real quick. So step 1, find E. So look for margin of error, says 2. Step 2, find sigma. Sigma equals 5.4. Okay. Step 3, find alpha. Alpha equals 1 minus 0.99, which is 0.01. Step 4, find Z alpha over 2. Now, if you remember, I told you there was 3 numbers worth memorizing. So if you remember 0.01, then Z alpha over 2 is equal to 2.575. So if you remember that, but if you don't, then you go to your calculator, you do second distribution, inverse norm, 0.01, except that's not right, it's 0.05, because 0.01 divided by 2. And then you press enter, and then it's right there, negative 2.575. If you do 0.575, sorry, 576, that's fine. I think I've seen both of them, just depends on the book. I would accept either one. I wouldn't be like that picky about it. And then step 5, plug in. Okay, hopefully I made this big enough, but I doubt it. 2.575 times 5.4 divided by 2. And then you're going to square that. And I get 48.3. Now, remember what the rule is for sample size, that if you get any number, you automatically round up. Always round up for the sample size problem. You will get it wrong if you don't round up. Okay. So that's all you have to do. Are there any questions on that? I want to make sure I haven't missed anything. Are there any other questions about one sample means? Again, no sample proportions, just sample means. No, you're right. There, I'll clean that up for you. Yeah, I should have been a little more careful about that. But no, you're correct. Any other questions? All right. So, before we move on, you do need to know the assumptions of all tests. And I did mention this in class, but just to remind you, right? So for a Z test and a T test, oops, pen's acting up. Assumption number 1, the sample is simple random sample. Number 1, the sample is simple random sample. I promise you, every single test has that first condition. Like every single one of them has that first condition. Number two, the population is normally distributed or n is greater than 30. Okay. The population is normally distributed or n is greater than 30. Number two for this one. The population is normally distributed or n is greater than 30. They really are the same. The only thing that's different is number three. Sigma is known. Sigma is unknown. Okay, that's it. Sample is simple random sample. Population is normally distributed or the sample is greater than 30. And sigma is known for Z and sigma is unknown for T. Any questions on that? Make sure. All right. Two sample means. Confidence interval. We'll do the confidence interval. So it's really not anything different. Okay. Well, actually, let's do sample mean. So in this case, you are testing differences. Okay. So H naught is mu1 equal to mu2, or the difference is 0. Okay. So if there is no difference, then 0 is your answer. You have 0 somewhere. Okay. The alternative is that it's not 0, right? The difference is not 0. So mu1 is bigger than mu2, or mu1 minus mu2 is positive, or mu1 less than mu2, or mu1 minus mu2 is less than 0, so negative. Okay. And then mu1 not equal to mu2, or mu1 minus mu2 does not equal 0. Okay. And so that is what you're testing. You're testing differences, right? So if your confidence interval contains 0, actually, I just will type in confidence interval. So if your confidence interval contains 0, there is no difference. Not significant. Okay. So if your confidence interval contains 0, it is not significant because otherwise it would. Or it wouldn't. Sorry, I said it backwards. So not containing 0 is like rejecting the null hypothesis, right? We'll talk about that in a little bit. But are there any questions? Okay. So the formula for it, how did I do the last one? I mean, critical value. I'm not even going to do that because I wouldn't make you calculate the degrees of freedom. So the confidence interval is mu1 minus mu2 less than x bar 1 minus x bar 2 plus t star times s1 squared over n1 plus s2 squared over n2. And then t star, oops, I forgot the x1 minus x2. Now, if you're wondering, again, what is t star? That just means it can be alpha or alpha over 2. So it's kind of a personal preference. like that. Okay. That's the confidence interval. But then again, your calculator does it too. Stat, test, oops. Well, there we go. To sample t interval. We didn't do z in this class, so don't worry about it. And then there, that's all you got to give it. And we always do no pooled. So no pooled. Okay. Any questions on it? So you just plug in the information and you're good to go. Okay. So let's just do a quick example. Given x1 bar is equal to 11, S1 is equal to 2, and N1 equals 50. I guess I should do it differently. X bar 2 equals 15. S2 is equal to 3. And N2 equals 40. Okay. Find a 90% confidence interval. Okay. So step 1, find x bar 1, x bar 2, S1, S2, N1, N2. Right, we have to find all of those things. Seems kind of redundant, but you do have to do this on, say, the exam, because if you don't find the correct data points, then you're going to get the incorrect answer. Hopefully the interval's not too small. Like that. Step 2 is to find confidence level. So the confidence level is 90%. You don't need alpha because we write it as the confidence level. And then step 3 is Excel. Sorry, wrong class, calculator. In my other class we use Excel. So x1 bar is 11. Oh, just to make sure, go to stats, go all the way down to sample t interval. Please make sure you click on the correct one. X bar S1 is 2. N1 is 50. X2 is 15. S2 is 3. And then N2 is 40. Remember, 90% for confidence interval, and then pooled is no. Don't ever make it yes. And then keep going, calculate. There is our confidence interval. Now let me ask you a question. Oops, 922. Because this is going to be something important that you might have to answer. Can this interval contain 0? Yes or no? Is it possible for this interval to contain 0? No. So this interval cannot contain 0. So then what would that mean about my null hypothesis? What could I conclude about my null hypothesis, which I claim to be 0, right? I claim my null to be 0. So then what can I say about my null hypothesis? If you were to make a logistic conclusion. You wouldn't want to say the null hypothesis is significant. What you would want to say is to reject it. Like it's basically like you don't want that, because if my interval can't even contain the null hypothesis, then I probably isn't going to be the correct one. So we should reject it, right? So 0 is not in the confidence interval and we want to reject, right? All right. Let's do 2 sample t-test hypothesis. Okay. Any questions? Just want to make sure. Just give me one sec. So if it does not contain 0, you fail to reject? No, you reject if it does not contain 0. If it contains 0, then that means it is possible for your population parameter to be 0 and therefore not be significant or no difference, and therefore you fail to reject. In the other case, where it can't contain 0, there's no possibility of you having a null hypothesis that's true, so it's reject. So I'll write that down for you. If interval, no, I mean, I wrote it down over here. Sorry, I remember. If your confidence interval contains 0, there is no difference, not significant. If it does not contain 0, then there is significance, and you reject H naught. Okay, fail to reject. All right, give me one sec. Okay, so we're gonna do an example of match pairs and then we'll cut it off there because I'm just not feeling well. So here's the example. I'm gonna give you a table of values. And this is the height of president. And then height of opponent. And then both of these are in centimeters. So here's the idea, right? The idea is if you have two presidents and you looked at their heights, one would surmise that the taller president would be favorable because we might view taller people as greater leaders, just because they're larger, which means stronger, and so on, right? There is a theory that states that if TV had existed when Roosevelt, FDR, not Teddy, was running for president, that he wouldn't have won because he was in a wheelchair, right? So they say that because of, that's why he was able to win so often. Well, I mean, that's not the only reason, right? But they say that that would have hindered him had he, people have been able to see him in the wheelchair. So here, what we want to know is, does height matter, right? So the question is, does the height difference matter, right? Does the height difference matter? Assuming alpha equals 0.05, right? So does the height difference matter? So in the chat for me, just type real quickly, because this is going to be the most important thing. Is this a two sample independent or is this a match pairs? Well, hopefully it's obvious, right? But what makes it match pairs? Well, you're looking at one pair of data and how they relate to each other, right? Do you guys see that? You are looking at pairs of data and how they match each other. So do you need to know the 8 steps? Well, the 8 steps are the 8 steps. Whether you write them all down or skip some, it's up to you. You could just throw this all into your calculator and get the answer. But it's a train of thought because all the tests are very similar. So you have to kind of know which one you're doing, right? So step 1 is the population parameter. Okay, what is the population parameter? So in this case, the population parameter is going to be the mean difference. We just call it mu d, right? And then what kind of test is this? Well, this is not a two sample test. This is a t-test, not two sample. Okay. It is not a two sample test. It's a t-test. So make sure you don't use two sample on the exam. Okay. Number 3. Whoa. That was very strange. There we go. Number 3 is going to be, what is H naught? Well, let me go over here, I guess. Is what is H naught and HA? So for any matched pairs, I promise you, mu d is equal to 0. Because if there is no difference, then it's 0. So this means there is no difference. Now, did I make any claim about what's it called? It being bigger or less than? I did not. Okay. Apologies. I need one more number here just because otherwise my answers aren't going to be right. So there was one more pair. The alternative is I want to know if they're different or not. I don't care about bigger or smaller. I just want to know, like, does it really matter? Right. So not equal to 0. So there is a difference. Good or bad? Just need to know if there's a difference. Okay. Now, if I said, I believe, or I think the alternative is that the president has an advantage, okay, well, then we would say, oh, it's greater than or less than 0. So then the question is, how do I know which is which, right? So that's where you have to read the directions, and they will tell you how to calculate D, because, and I will do this for you. I will tell you which one to subtract, because if you do it backwards, you'll just change all the interpretations. So for this one, it's going to be president minus opponent. Okay. So the first one minus the second one. So that's how we're going to calculate D. It's going to be president minus opponent. Now, for this type of problem, step 4, you actually have to compute D bar and SD. Okay, so this is something where you do have to compute it. Okay, so to calculate D, okay, you go to each one and you subtract them, right? And I wish I gave myself more room, but I will just draw a line right here. And so you're going to subtract all of them. And so 195 minus 191 right here is 4. Negative 4. 4. What would that be? 8. Negative 18. And then 4, right? So those are all of my differences. So then D bar is just the sum of those. So D bar is equal to 4 plus negative 4 plus 4 plus 8. That's an 8, right? Plus negative 18 plus 4. And then I divide by 6. Okay. And then if I calculate that, which I'll do off to the side, unfortunately, give me one sec. So 4 plus 8 plus 4 minus 18 is negative 2. So negative 2 divided by 6. So negative 0.333. Okay, just want to verify that one more time. 4 minus 4 plus 4 plus 8 minus 18 plus 4 divided by 6. Yep. Okay, so that's my D bar. Now, SD, you don't want to do this by hand, but you can. But remember, I showed you in the calculator. You go to stat. You edit your list, and then you type in your numbers. 4, negative 4, 4, 8, negative 18, 4. And then you click on stat, you go to calc, 1 var stat, calculate, and there it is. And that also verifies that X bar is correct, right? So my standard deviation is SX, which is 9.5008, like that. Step 5, find alpha. So did I give us alpha for this problem? 0.05. Step 6, find p-value. So remember, you got to use the t-test. So stat, test, t-test, and then mu naught is equal to mu d, x bar is equal to d bar, and sx is equal to sd. You just have to remember that. And n is equal to the number of pairs. I cannot stress this enough. Do not put the total number. It wouldn't be 12, it would be 6. So 0, negative 0.3333, 9.5008, n equals 6, not equals. And then my p-value is 0.9348. Okay, 0.9348. P-value is equal to 0.9348. Like that. D bar represents the average of all of the differences from each one. So this one minus this one, this one minus this one, this one minus this one, 193 minus 185, 182 minus 200, and then so on. Does that make sense? I mean, you can get really big p-values, so it happens. So step 7, reject or fail to reject. So 0.9348 is bigger than 0.05, so we fail to reject. So there is not sufficient evidence to say that the height matters. Okay, there is not sufficient evidence to say height matters. Are there any questions on that? So I did post the solutions to the quiz, so I would recommend looking over that. I went into detail. I mean, I can just kind of pull it up right here if you give me a second. Right, so I went into detail on all of them, and especially for the match pairs, I go into like what each step is. I even explain little things, so like less than 0 means less accidents on the 13th, greater than 0 means more accidents on the 13th, right? So just definitely look over this. And you know, for a confidence interval, I go over it in detail on which one to use. And yeah, so I would definitely review that before tomorrow. In order to be more confident, the interval has to be wider, so that you have a higher probability of hitting the population parameter. So overall, the only thing I wasn't able to cover was just the 2-sample t-test. But if you understand match pairs, or even just the 1 sample, all it is stat, tests, 2-sam t-test. And it's just the same. It's all the same, right? It's really all the same. So, but any questions? I apologize. I'm just not feeling well right now. So I don't think I can do the last example. All right, no questions. So I'm going to stop recording and post this immediately.